Good afternoon, Algebra 1, periods 1, 6, and 7. This is Mays coming at you from room 308. It's Thursday, it's the 14th of May. Hope you guys are all having fun. I know I am. I'm working quadratics. What could be better than that? All right, today I would like to provide a little insight into chapter 9, section 9.6. Section 9.6. It's solving systems of nonlinear equations. And the example I'm going to show you today, it's a parabola and a line, okay? Now, your textbook does a pretty decent job of showing you what all this can happen. But anyway, this is the basic three outcomes that if you're given a system, a parabola and a line, this is the three possible outcomes. Here they are. All right, you may have a situation where they do not intersect. In other words, there's no point of intersection. That POI, that means point of intersection. There's no point of intersection. We try to solve this, you're going to get something that makes no sense. You know, 9 is equal to 12 or something silly like that. That will tell you there's no intersection, okay? Or you could have a case where you find 2 points of intersection. When you solve this, you'll find 2 x values, and then you'll find the 2 corresponding y values that match those, okay? 2 points. Or you may have a case where there's only 1 point of intersection, that little point of tangency right there, 1 point of intersection. Now the example I chose is going to illustrate the third case there, all right? So here we go. Chapter 9, 9.6, Algebra 1, solving a system of nonlinear equations. And you will have the opportunity to do this on your semester test, so pay attention. All right, so this is what I started with. I started with these two equations. F of x is equal to x squared plus 7x plus 12, and f of x is equal to 3x plus 8. Now remember, f of x, that's function notation. It's just the name of the rule and the variable is x. If you jam something in for x, it's going to give you a y value, all right? That's why f of x and y they're like interchangeable. You can think of it that way. So what I'm going to do, I'm going to say, all right, y is equal to x squared plus 7x, and y is equal to 3x plus 8. I'm going to make the assumption that these two intersect, okay? And we'll see if the math supports that. Now, at a point of intersection, the x and the y value are exactly the same value. So therefore, if the x and the y are exactly the same value, I'm going to take those two y's. I'm going to say, okay, that is the same value. Those two y's are exactly the same thing. The same y is equal to x squared plus 7x plus 12, and that same y is equal to 3x plus 8. So I can set them equal to each other, which is exactly what I'm going to do right here. I'm going to set them equal to each other. X squared plus 7x plus 12 is equal to 3x plus 8. Now, set it equal to 0 and solve, okay? Now we're back into familiar territory. Okay, if I subtract 3x and subtract 8 from both sides, I get x squared plus 4x plus 4 is equal to 0. And now I get to factor and solve. All that chapter 7 stuff coming back at you. Okay, now I happen to recognize that x squared plus 4x plus 4 is a beautiful, perfect square trinomial. And it factors into x plus 2 quantity times x plus 2 quantity. If I set it equal to 0, I can solve each factor. Do I really need to do both of them? No, I only need to do one of them. All right, so if I take that factor x plus 2 and I set it equal to 0, because remember, the zero product rule says that that's equal to 0, then 0 times anything is equal to 0. That's why we can do that. Subtracting 2 and x is equal to negative 2. Now, if x is equal to negative 2, I can take that negative 2 and I can plug it into either one of these two equations. It doesn't matter which one. I'm going to do both of them just to show you that it works, okay? All right, so if x is equal to negative 2, then 3 times negative 2 plus 8 is equal to 2. Negative 6 plus 8 is 2. Or you could have plugged it into the x squared plus 7x plus 12. Negative 2 squared is 4. 4 minus 14 plus 12, the same 2. Okay? All right, so negative 2, 2 is your one and only one point of intersection. Now, had you gotten 2 factors here, 2 different factors here, you'd have got 2 different values of x, and you'd have plugged each of those values of x into, I would do this one, it's a whole lot easier, and I would have found 2 points of intersection, okay? All right, so that's a brief 9.6 rundown. You will have an opportunity to do one of those on your semester test. Okay, now, tomorrow, the 15th of May, I do believe that the Power School or Plan Book or whatever it is says that pretty much everything is due tomorrow that's posted so far. Now, I've been a little bit reluctant to put any more stuff out there because I realize that there's a lot of you that are catching up, okay? And I don't want you to feel like it's an insurmountable task to complete this. If you're caught up, hey, great. Kick your feet up for a day or two, relax, and do some review, okay? For those of you who are still catching up out of chapter 10 and you're working on chapter 8 and you're working on chapter 9, hey, great. Keep moving, okay? Get that quadratic worksheet filled out, get that turned in. That's kind of a big one, okay? Now, I mentioned earlier I was going to post the solutions to that out there. I decided not to because not very many of you have turned it in. And I get a little irritated when I post answers out there and then, 2 days later I get a barrage of papers that are all perfect because all you do is copy the answers down and you don't have a clue what you did, okay? So anyway, I'm going to hold off on that. So sorry. So please get that done, get that turned in, know how to use the quadratic formula. And when I say quadratic formula, man, pop it into your head should be x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. That should be bing, automatic, okay? And know how to use it. That's going to be a very large portion of your semester test. Solving systems of equations, linear and nonlinear. You're going to see some of that, all right? And I love that negative 16t squared v sub naught f sub naught stuff, okay? You've got that football problem in your book. You've got a dolphin problem in your book. You're going to see it. Get used to it. And I've got your semester test cranking. Points of intersection. I'm going to give you 3 lines that's going to generate a triangle. I want all kinds of cool things. I want vertices. I want areas, all that kind of stuff. So start studying. Start studying, okay? Do some review. Go back and look at how to find a point of intersection for 2 lines. Make sure you got 9.6, point of intersection for nonlinear systems. And make sure you got that quadratic formula. Make sure you got it. All right, that's kind of where I'm at for today. So have a great day and enjoy your quadratics. What could be more fun than that? All right, May's out.